Okay, so welcome to our little short webinar on the 2013 National Youth Science Day Experiment. We want to just do this quick webinar for you to get you up to date on what the experiment is and just some basic instructions for how it's going to work. And all of you should be getting your science kits pretty soon. I think everybody except Sasebo and Kwajalein were mailed last night. So you can be expecting them at any time. So what's this about? So it's about GIS mapping, or Geographic Information Systems, and it's related to GPS, or the Global Positioning Systems. And this experiment is what I'm calling kind of a low-tech way of taking kids through the process of GIS mapping. So there's no special software or equipment needed, and they're still going to be able to create their own map. Okay, and it was developed by the Colorado State University, and it was developed with the idea in mind that it would be accessible to all youth, regardless of income level or where they were located. So I think it's great that they did it this way, and there's no special equipment that's really needed. So why are we doing this? It's to help youth to think like a geospatial scientist. And some examples of where we have geospatial scientists working or what they're doing, examples would be like Google Maps, Yelp, Google Earth, any kind of hiking GPS that you might use or one in your car, city and county planning. Development company use this technology and this thought process and this methodology of geographic planning. So there's a lot of really different ways that these kinds of maps and this kind of thinking can get used. And I would encourage you to think about those things as you're going through this, and with your kids, especially if they're a little bit older, like, you know, maybe 6th grade and older, if you're going to be doing it with some of that age group, to start thinking about which kinds of jobs might need this kind of thinking or this kind of process involved. In your facilitator guide, which you'll get either in your kits or I'm going to show you on this webinar today how to download them, there is a geographic inquiry process. And this is really kind of cool because it's taking you through a 5-step process that geospatial scientists go through. So the first thing is to ask some kind of geographic question. The example that we have in our books is, why is there more garbage in some parts of our playground than others? Okay, and then the second part of that process is to acquire geographic resources. So you might map the location of trash on your playground. And these kinds of activities can be done with, I mean, literally just a clipboard and a piece of paper. So you could go outside with your kids even before you get your science kits, or maybe as a follow-up activity to this experiment, and do some mapping. Mapping of trees, mapping of trash, mapping of whatever, and map the location of the trash that's located on the playground. The third part of it is to explore that data. So you're going to look at, maybe ask some questions like, how many trash cans are there in the area where you find the most trash? Okay? And the fourth part of it is to analyze the information. Does your map offer any evidence as to why it accumulates in certain places? And this is where you take into consideration things like fences, wind direction, or whether certain parts of the playground maybe don't have any access to the trash cans, or maybe there's picnic tables nearby and so people's lunch rubbish flies around. So these would be kinds of your questions you would ask. And then the last part of it is to act upon that knowledge. So do you think that providing more trash cans would help? You know, having the kids think about solutions. Once they've done a mapping activity and discovered a problem or found out more information about a problem, how are they going to then solve it? I want to pause for a second, and I'd just like to get a little feedback from you guys. Just a quick yes or no in the chat box of if any of you have gone online yet to explore some of the website or any of the information yet. Okay, thanks, Tiffany. So your FGS has taken a look at some of this stuff. How about some of the other programs? Have any of you taken a look online yet to see any of the information about the experiment this year? I don't want to go into too much detail with you on the webinar if you've already explored some, but I do want to give you a basic kind of overview. So what's in the kit? This is what's in the kit. This is a picture of exactly what the kit looks like when you open it up and lay it out. So inside you're going to have one facilitator guide, which is the book that's on the right side in the picture, and then you're going to have 5 youth guides, a box of dry erase crayons, and the top sheet in that picture, you can see that there's kind of like one sheet lying on top of some others. The top sheet there is what's called the base map, and underneath of it are 8 plastic sheets that are clear that also have the same grid lines printed on them as the base map. And what this is it represents an 8-acre park that your group will design. The topography lines have already been done for you. So the hill that exists in the upper right corner of the map, that's represented by the topography lines. And this is what the kit looks like. So the only thing that you have to provide in order to do this activity are some binder clips, which would be helpful for when you're clipping the maps together. And then also this is the feature layer cards sheet. And this is located, it's a sheet that's in the facilitator guide, appendix page B. And what you do is you just cut out this page, you photocopy it, and then you cut out these cards. And they end up looking like little strips, okay? And these are the layer cards. So there are 8 layers, and there are 8 clear plastic sheets. So you will be developing a map that has 8 different layers of information on it. I'm going to pause for a second. Does anybody have any questions yet? Okay, so where can you find the guides? This is a screenshot of the 4-H.org and the National Youth Science Day portion of the website. So if you just go to 4-H.org and click on National Youth Science Day, this is where it takes you. The information about this year's experiment, where we're going to go in just a minute, is where this green arrow is pointing, the 2013 experiment. There's also, if you look down that list in the yellow box, event registration. I would definitely encourage you to register your events. This looks really cool on the world map that they put up online of where all of the different sites are that are doing the experiment. And right now, I believe, I just checked yesterday, excuse me, and there's only one little dot or one little like pinpoint on the map for Hawaii, and that's on our one of our Navy sites on Kauai. And then there's one in Japan at Misawa, and also one in Korea at Osan. So if you guys are going to do this experiment, please go and register and get yourself on the map so that we can see you, because it looks pretty cool to have the little dots speckled across the Pacific and into Asia about who's all doing these experiments. I would like to try, I have tried this before and I'm going to try again. I'd like to try and do a web tour and to show you the video. So if you just want to hang tight for a second, talk amongst yourselves for just a moment and see if there's any questions. You can type them in the chat box while I get you guys set up to go on a little web tour and watch a video. Okay, Okay, can everybody see the website in front of you now? Little happy face if you can see the website and the scrolling picture bar at the top. Anybody? Okay, good. Good, okay, Tiffany can see it. How about Camp Casey? Lee, thanks for joining us. If you can see it, just give me a little smiley face in the chat box. So that way I know that you can follow along while we do this little web tour. All right, so this is the main website, and see how putting it on the national map, you can see that they have a little map there. What we're going to do is scroll down. We're going to go right over here to the experiment. And I'm hoping that you guys are going to be able to hear this video. So we're going to watch the video live. Watch the 4-H Apps and Maps how-to video.
Cards and change facial features to get things started. For example, human-made polygon features include pools, playgrounds, and tennis courts. If there are two group members who want to design the same layer, all layer cards together face down and have each team member select randomly from the group. Next, take the base map to the table and gather as a team to begin planning your part. As designers, it is important to think carefully about your concept, the general goal, or theme for your part. As ideas are created, the lead planner will start taking notes. If you're having trouble thinking of an idea, consult your Maps and Aptitude Guide for more discussion. Okay, let's figure out the order of the future layers. To make your GIS model, you will need to work the way the GIS software does, by creating layers of related features and placing them on top of each other. As a team, use your base map and feature layer cards to decide the most logical order in which to add layers to your map. Record the order in the Maps and Aptitude Guide.
Okay, so I guess either my chat message or my audio was delayed or something. I was playing a video for you guys. Anyways, this is really frustrating for me because I've tried this out so many times, and the people in our office can all see the video when I've tried it out, but when I have you guys do it, no one can ever see the online videos. So I will not keep you here for a long time today, and hopefully you guys can go and watch it yourself on your computers. But it's about a 5-minute video, and it shows you the kind of the comprehensive, like from start to finish, what the experiment is about. For right now, I'm going to try and show you what the facilitator guide looks like, and maybe give you a little more insight on why why this is important, and some talking points to work with your kids. So we're going to try to do an application share. And let me know if you guys can see this in front of you. So this should be an Adobe PDF file in front of you, and you should be able to go through it with me. So give it a little smiley face if you can see it. Okay, well at least this is working. So this is what the facilitator guide looks like. And you'll get one of these, like I said, with your kit, but you can go ahead and download one today and print it. They also have a grayscale version, so if you don't have a color printer or you don't want to use so much color ink, you can print it in black and white, which is kind of nice. The introduction is really kind of nice because it explains a little bit about why we would be doing this. And it talks about how in history people have always made maps about their physical locations, and that exposing young people to this kind of mapping, this GIS mapping, helps them experience firsthand this technology and can help them solve some real-world problems. And it also is going to give them a taste of how geography really impacts our human life and how the built world, the things that we decide as human beings to build around us, how much thinking actually needs to go into those things. We don't just plop a building anywhere. We have to really think carefully about how we do that. So there are two different activities. The one that we're focusing on just for the main activity is this one called Park It, Be a Layer Player. And its youth will become community designers and create a GIS map of their own unique version of a park that makes their community a better place to live. So that's what the main kit is for, is to create this map, okay? The second part of the experiment, if you want to go a little bit deeper and maybe you have a group of kids who really, really liked that map creating, then I would suggest going and doing the second activity called problem layers, or talking about trash. And so that is where youth will explore how GIS layers can be used to assess a messy situation by looking at data plotted out on a map and propose cost-effective solutions. Okay, so that one might be a little more advanced, but definitely at least start with the park design map and see how it goes and see if your kids are really interested, and then maybe go on to the second activity. So the guide is laid out really well. There's these different kinds of icons that you want to take a look at, and it's really clear how to use it. The geographic inquiry process is right here that I introduced you to on one of the slides. So that's really nice. It's all right here for you. There's a lot of different graphics and pictures and stuff, and explaining what GIS is. So for those of us who this is kind of new for, explaining that geographic information system is designed to organize, analyze, display, and to share all types of geographic data. And so it typically uses hardware like computers, software programs, spatial data, or just information, and you, the curious mind, to collect information, identify patterns, and gain new insights about the world and human activity. Spatial data, or what they're talking about is the geographically referenced information, is any information that can be associated with a location and then placed on a map. So the example they give is the spatial data could be an area's population density, its frequency of earthquakes, the median income of residents, type of trees, or the location of recycling centers. All of this kind of information can be placed on a map. So one of the most powerful features of GIS is that it allows a variety of different spatial data to be incorporated and analyzed on the same map. Okay. So it kind of goes through and gives a little examples about where these kinds of mapping can be used and why it's important to understand it. Anatomy of a GIS map. So you're going to learn, how scale is important. On your maps that you have in your kits, the 1-inch square equals 20 feet. So though it's not required, I would suggest having a tape measure on hand so that as you design your maps, the kids can get a really good sense of what 20 feet looks like. So the 30 by 30 sheets that you get represent 8 acres. And that's a lot of space to think about. We just did this activity this morning with our 4-H leaders here on Oahu, and for those of us who are island people, 8 acres seems like an enormous amount of space. So having them have a visual of how much 20 feet looks like and that each square on that map represents 20 feet would be useful, I think, especially for the younger kids. Again, talking about scale, these are your layers, okay? You're going to have 8 layers to your map, and that's why you have the 8 different colored crayons and the 8 pieces of clear plastic sheets that you're going to have in your box. the first part is that you're going to basically sit down and ask your group, what is it that we want out of this park? You know, we've been tasked with designing a park. What do we want it to be? And you're going to brainstorm, okay? So you're going to brainstorm with your group, who's it for? What kind of features do we want to see? You know, what is it that's going to draw people into our park? And you're just going to brainstorm all of those things. So that's kind of what this is talking about, and that in teams of 8 participants would be ideal. If you have less than 8, it just means that a person might be responsible for more than one layer of the map. And if you have more than 8 participants, then you might have to double up and maybe create like 1 2-person team to work on one layer of the map, for instance. The other idea that came up today in my discussion with the leaders, and I think this is a really good one that I'll share with you guys, is that one person said, well, you know, I think we're just going to make this like a week-long activity, because she's got 5 teens that really want to do this, so she's going to have them do a layer every day for a week. You know, maybe 2 layers on one day or whatever to get the full 8 layers completed, but that she's not going to do it all at one time. And so I think that's a really great idea if that would work for you. If you wanted to lengthen the activity and work on one layer at a time, you could definitely do that. So the 8 feature layers are hydrology. So this is water, vegetation. These are things that occur, things you're going to make occur on the map as if they were naturally there, okay? They didn't give us that information on the map, so there aren't any ponds or trees or anything on the map already. But what you're going to do is you're going to put those things on the map as if they were already there to start with at your site, okay? Then the next layers are going to be the human-made polygons like recreation, the human-made structures, and then other human-made features. And then human-made line features like roads, pathways, maybe bicycle paths, and then point features like recreation, and these would be things like park benches or picnic tables, and then the natural features added by humans. So these are going to be things that you're going to add, like once we get all of these other features down, where do we want to put shade trees? Where do we want to put flowers? These kinds of more things that can be built around other structures, okay? So designing with the end in mind, and as designers, to encourage the kids to think really carefully about the concept, the general goal or theme. So this is often referred to as beginning with the end in mind. So as a team, discussing and deciding what you want your park to do for the community, and brainstorm and record a list of things that you think that the park should have. Once you have the things determined that you want your park to have in it, you're going to determine the order in which you're going to put those things, which layers you're going to have. So the first layers, like I said, are going to be the natural features, the vegetation and the water. After that, it's up to you. You decide which layers you want to put on top of which ones and what order you want to be them in. Then what you're going to do, you want to assign the features that you talked about in your concept phase. You want to assign those to a layer. So for instance, if during your brainstorming stage everybody said, oh, well, we definitely need a playground. Well, where does that go? Is that a human-made polygon feature, or is that a natural feature? So you have to decide what layer to place it on. And the person who's responsible for that layer is going to write down that concept idea on a sticky note and put it on their map so that when they're designing their piece of it, they know to include that. Okay? I'm going to pause for a second. Do you guys have any questions so far? Am I going way too fast? Okay, well, I'm going to keep on going then. I want to get you guys done in about the next 10 minutes so that you can spend a little time going and exploring the website yourself just to see the video that I wasn't able to show you. So this just reminds you to pay attention to scale and to, as facilitators of the activity, to make sure that everyone's voices gets heard and that that their ideas are presented. So then you're going to start drafting, and as each team is satisfied with their design, you're going to just ask them to draw their features on their layer sheets and then ask them to pay attention to each other's contributions because every layer is dependent on the ones that go before it. So for instance, you don't want to have your playground in the middle of a parking lot. So they're going to have to do some communication with each other. If I'm working on the human-made structure feature, like a picnic shelter for instance, and somebody else wants to put their community garden in the same exact spot that I'm building my picnic structure, then we're going to have to work out, well, which is the better site placement for that and why. Okay. Then this step 6, the applying the geographic inquiry. These are your processing questions. So those things I harp about all the time of doing your processing questions for an activity, your ESPGA, the Experience, Share, Generalize, Process, and Apply. The questions are already here for you. So all you've got to do is go to this page and then start asking questions. So were there any features that had to be changed because of the geography of this site? What possible effects on the environment did this map help you to identify? And how did you decide what needed to go into each layer? How did creating your map in layers let you do things that might have been harder if everyone was just trying to draw their ideas onto one map? I think that's a really good question. So if everybody was trying to draw everything on one map at a time, how would that process look differently than doing this layered approach? So once you've gone through all of this and you have your park design, after it's been tweaked and edited a little bit to make sure that we don't have water features in the middle of a parking lot, you can go here to 4-H.org and to post your park design. And you can take a picture of the map and post the image onto the National Youth Science Day photo gallery and identify your site, and so that they can see what their park looks like in comparison to youth from all over the country and in fact the world, because there are military installations all over Asia and Europe that are going to be doing this too. So it's kind of exciting to see what the kids are going to come up with from all across different places. I'm going to stop here. The rest of the facilitator guide goes into different activities and different parts of the experiment that you can do, you can add on. This park design is the primary experiment, and which is the one we really encourage everybody to at least do this one. If you continue on and do the rest of them, that's great too, and we would love to see pictures of all of that. But I am going to stop and let you guys type any questions you have into the chat box, and I'll just stop for a second. Okay, so if nobody has any questions, it's almost 2:40. I just want to encourage you to explore the website for about 10 or 15 minutes after we get off this webinar with each other. Go and watch that video, please. I'm sorry it didn't work for us right now. And also go ahead and download the facilitator guide so that you guys can read it and get familiar with what it's going to look like once you get your kits. And then plan a date. And if you have a date already in mind, we'd love to hear when you're planning on doing this experiment and who you're planning on doing it with. If there's a particular club you have in mind, or you're just going to do a general, site-wide experiment or whatever, let us know that information so we can start to look for you guys on the National 4-H Science Day map. And I'll continue to check there every couple of days and see if you guys have registered your events. So without any further questions, I'll leave it open for just a minute in case you guys want to type something. But thank you very much for attending, and we're looking forward to seeing what you guys do for this experiment. Thanks.